And now we will discuss problem based on method of join. So in engineering mechanics, we discuss the problem based on method of join. So by this problem, we can easily see how we can calculate forces in each and every member of given truss. So let's take a simply supported truss. I am just trying a simply supported truss. I am saying simply supported because the support I will use for this problem will be the simple support. So this one is the simply supported B. Here we are having the simple support A, and at that point we are having the another simple support. Here we are applying the point load. And now I will say this point is B, this point is C, this point is D, and this point is E. And here we are applying the force of 20 kilonewton. Here we are applying the force of 8 kilonewton. And here I am applying the force of 12 kilonewton. And if you see the distance here, it is 2 meter. And if you see the distance here, it will be feet. And if we talk about this angle, it will be 60 degree. It will be 60 degree. So it's a complete description of the given truss. It is simply supported truss where the A points and D points are the support points. We are applying the force 8 kilonewton at B, 12 kilonewton at C, and 20 kilonewton at E. So our first step, we have to find out the reactions at the support. So say for simply support reaction is RA. So now we are applying condition number 1, that is algebraic summation of all vertical forces should be 0. Vertical forces in vertical direction, we are having sign convention: vertically upward positive, vertically downward negative. I am talking about in y direction according to our coordinate axis, that is x and y. So according to this equation, there will be plus RA because RA is acting in upward direction, plus RD, RD is also acting in upward direction, minus 8 because it is acting in downward direction, minus 12, and minus 20 equals to 0. So we can get RA plus RD equals to 20 plus 12 plus 8, and if we further solve it, RA plus RD equals to 40 kilonewton. So this is the first equation. Now there are two unknowns RA and RD, so we have to use one another equation. So we can use moment equation. Algebraic summation of moments of all the force about A should be 0. So at A point there is a RA. So RA is passing through A. So perpendicular distance is 0. So moment is 0. So we can write RA into 0. If we talk about this distance, it's a equilateral triangle. Uh, Here it is mentioned, so it is we can say that 60 degrees here. So it's an equilateral triangle here, and if we talk about this distance, suppose A AF. Suppose we are calling this distance is AF. So AF will be perpendicular distance for that. So here I am having RA, and moment due to this 8 kilonewton, it will be 8 into perpendicular distance, it will be here this distance AF. So I am just writing now AF, and the nature of the moment is in clockwise direction, so positive. So I am defining the sign convention: clockwise positive, anti-clockwise negative. So now we are having 8 kilonewton, this line of action here, into perpendicular distance AF. Similarly, moment due to 20 kilonewton, 20 into perpendicular distance will be AE. Perpendicular distance is here AE. This one is the perpendicular distance for, and the nature of movement is clockwise direction, so positive. Similarly, for this 12 kilonewton, the line of action is this. Suppose it is coming at G. So we can say that 12 into perpendicular distance is AG. Again, it is in clockwise direction, so positive. RD into the perpendicular distance here, it will be 2 plus 2. So it will be 4, and it is in anticlockwise direction, so it's negative. So now we can easily see this thing here. It is 0. Here at the value of AF, the value of AF is nothing but 2 cos 60. The value of AF is nothing but 2 cos 60. 2 cos 60, right? And if we talk about this thing, 20 into AE, so it will be 2 plus 12 into AG, it will be 2 plus EG. So we can write 2 plus 2 cos 60 minus RD into 4 equals to C. So now we can further write this thing 8 into 2, 16 cos 60 is nothing but 1 by 2 plus 20 into 2, that is 40, plus 12 into 2 plus 2 into 1 by 2 equals to 4 RD. So this thing is 8 plus 40 plus 12 into 2 plus 1 equals to 4 RD. So this will be 8 plus 40 plus 2 plus 1, 3 into 12, 36, 4 RD. So we can write 4 RD equals to 40 plus 36, 36 plus 8 will be 40 plus 36, it will be 76 plus 8, it will be 84. So we can see RD will be 54.4, nothing but 21 kilonewton. So by this way, we can calculate the value of RD, which is nothing but 21 kilonewton. We know this thing RA plus RD equals to 40. So we have already find out the value of RD. So RA will be 40 minus RD. So 40 minus 21, so it will be 90 kilonewton. So in first step, in solving the problems by method of joint, we have to find out reactions by applying the conditions of equilibrium. So we have already find out the value of RA and RD. The second step, we have to identify the joint where the number of unknowns are 2 or less than 2. So if you see the point A, in point A, I am drawing the free body diagram of point A, because I am selecting the point such that there will be a number of unknowns 2 or less than 2. So let's talk about A point. In A point, there are two members AB and AE. This angle is 60 degree, and we have to find out the force AB and force in member A. So our assumption, all forces in members of truss are tensile. And if you are assuming all forces in members of truss are tensile, then you have to show with the help of arrow. So for showing the tensile force in the members, we will show the arrow away from the joint. Suppose I want to show the tensile force in AB, so it will be like that, that is away from joint. It is the joint, so it will be away from joint. Now we can apply the conditions of equilibrium for solving it. We know the value of Ra, it is 19 kilonewton. So we can apply the conditions of equilibrium for solving this thing. So let's take condition number 1. It is algebraic summation of all horizontal forces should be 0 or forces in x direction should be 0 according to our convention. This is positive, negative, x is negative, positive y is positive, and negative y is negative. So for positive direction, we are having FA, that is in positive x direction. Similarly, the component of AB in that direction will be FAB cos 60 degree equals to 0. This is the equation we got from our condition number 1. Similarly, for condition number 2, algebraic summation of all vertical forces should be 0. So in vertical direction, we are having FAB sin 60, the component of FAB in vertical direction, plus RA equals to 0. So if we solve it, so FAB equals to minus RA divided by sin 60. So it will be value of RA we know that is 19 and sin 60 value root 3. So it will be 38 by root 3 kilonewton and the sign for that is negative. So right now we are not bothering about the sign. We will solve the equation on the basis of mathematical formulas, like suppose the value of FAB is minus 38 by root 3, then for substituting in the further equation we have to put with the magnitude as well as sign. So this thing we have to remember this thing, and after solving equations for each and every member, we will make the table, and we will think about what is the meaning of positive sign and what is the meaning of negative sign. So right now you just understand whatever the sign is coming, you have to use this sign for the other equation, solving the other one. So now we are having the FAB, it is nothing but 38 by root 3. So now we can use this 38 by root 3 in our previous equation. So now our previous equation is FA plus FAB cos 60 degree equals to 0. Here we are interested in FA and we know the value of FAB, that is nothing but 38 by root 3, and cos 60 is nothing but 1 by 2. So here we will get the value FA equals to 19 by root 3 kilonewton, and sign is coming positive. So we have solved for one case. Here we identify the joint where the number of unknowns are 2 or less than 2. So that's why we choose first A. Let's take joint B. So I am interested in free body diagram of joint B. Why I am taking joint B? Because after A, the number of unknowns at joint B are 2 or less than 2. So let's draw the free body diagram joint B. At B, there is a vertical load of 8 kilonewton is coming on it. There are three members. One is this member, second one is this, and third one is this. This is the point B. And according to our assumption, assume all the forces in the member plus a tensile. So for showing, it should be away from here. It is joined, the arrow will be away from it. It is joined, arrow will be away from it. It is joined, arrow will be from it. We can easily mark this will be the FBC, this one will be the FBE, this one will be the FPK. So this is the force diagram or free body diagram for that. And if we talk about this angle, so by geometry we can see that it is 60 degree and it is also 60 degree. So this one is the free body diagram for joint B. We can further simplify this diagram. So this whole angle is 90, so it will be 30 degree and it will be 30 degree. So after drawing the free body diagram, we can apply the conditions of equilibrium. That is first condition. Algebraic summation of all horizontal forces should be zero. I will again draw my coordinate axis. It is x and y. So this one is positive x, this one is negative x, this one is positive y, and this one is negative y. So I'm applying the condition number 1, algebraic summation of all horizontal forces, or algebraic summation of all forces along x direction should be 0. So in x direction we are having one force, that is FPC in positive direction, so plus. There is a component of FBE in horizontal direction. It is nothing but FBE cos 60, and there is a component of FBA in horizontal direction but in negative, FBA cos 60 degree equals to 0. So this one is the first equation and we know the value of FBA. Remember one thing, we know the value of FAB. It is nothing but the value of FAB is nothing but minus 38 by root 3 kilonewton. So remember one thing, if we say FAB, so we can also write FBA. So both value will be minus 38 by root 3. We have to consider this value with sign. If we put this thing here, we will get FBC plus FBE cos 60 means 1 by 2 minus FBA means minus of 38 by root 3 cos 60 is again 1 by 2. Let's do 0. So we are having FBC plus FBE by 2 plus 19 by root 3 equals to 0. So this is the equation we are getting from our first equation. Similarly, the algebraic summation of all vertical forces should be 0. So in vertical direction, there is a vertical downward force. So according to our sign convention, it is negative, so minus of it. There will be a component of FBA, that is FBA, in right cos 30 degree. It is in downward direction, so negative. Component of FBE, again it is in the downward direction, so it will be cos 30 negative. So we are having minus h. We know the value of EH, nothing but minus 38 by root 3. Cos 30 is nothing but root 3 by 2 minus FBE into root 3. So we are having this equation. So now we are having minus h minus of minus plus 19 plus 2 FBE into root 3 by 2. So here we are having 8 into 2 by root 3 plus 2 FBE. So for FBE, we are having, sorry here, it is 19 minus 8, it will be 11. So it will be 11 into 2 by root 3. So it will be, I am again writing FB equals to 11 into 2 by root 3. So it will be 22 by root 3 kilonewton. So we got the value of forcing member BE. That is, if we put value of FB is nothing but FBE equals to 22 by root 3 kilonewton. In our previous equation, that is nothing but FBC plus FBE by 2 plus 19 by root 3. That is our previous equation. That is nothing but FBC plus FBE by 2 plus 19 by root 3 equals to 0. We put this value, we are having 22 by root 3 into 2 plus 19 by root 3 equals to 0. BC will be minus 11 by root 3 minus 19 by root 3. So we will get minus 30 by root 3 value. It is the value of BC. By this way we can find out the value and and for joint C, so I'll draw the free body diagram. Joint C. In joint C, the force of 12 kilonewton is coming here. There are three members shown in figure. So from C, and for our assumption, all the forces is inside, so direction of it away from there, away from there, away from there. This force will be FCB, this force will be FC, this force will be FCD. When we talk about this angle, it will be the 60 degree. So here again we are having 30 degree, 30 degree, and this one is 60 degree. So this is also 60 degree. So this one is the free body diagram for joint C. So let's apply the conditions of equilibrium in case of joint C. First equation, algebraic summation of all horizontal forces should be 0. So in horizontal direction, we are having CB. First of all, I will draw coordinate axis x and y. It is positive x, it is negative x, positive y, that is negative y. So that is applying this equation minus xc, because in negative direction, minus xce cos 60 plus xcd cos 60 equals to 0. So this one will be the equation. Now just put the value of CB here. Nothing but minus 30 by root 3 minus FCE cos 30 is nothing but 1 by 2 cos 6 plus FCD but 1 by 2 is to 0. So we are having, that is 30 by root 3 minus FCE plus FCD, which is 2 equals to 0. So we are having 30 by root 3 equals to FCE by 2 minus FCD by 2 equals to 0. So that we can get equation which is FCE minus FCD equals to 60 by root 3. This equation we can get. Let's take condition number 2, that is algebraic summation of all vertical forces should be 0. So if we see the diagram, there is a vertically downward force, that is minus 12, because from our sign convention, positive y is positive, negative y is negative. So 12 is acting in downward, so minus. The component of FCE in downward direction, FCE cos 30 degree, negative. Component of FCD in downward direction is FCD cos 30 in negative direction, 0. So we are having the equation FCE cos 30 plus FCD cos 30 equals to minus 12. So here FCE cos 30 is nothing but root 3 by 2. FCD cos 30 is nothing but root 3 by 2 equals to minus 12. So this thing will come FCE plus FCD should come minus 24 by root 3. So now we are having two equations. FC plus FCD minus equals to minus 24 by root 3 and FCE minus FCD equals to 60 by root 3. If we solve this equation here, so we will get twice FCE equals to minus 24 by root 3 plus 60 by root 3. So twice FCE is to 60 minus 24. It will come 36, positive 36 divided by root 3. So FCE will come 18 by root 3. The value of FCE will come 18 by root 3. And if we put the value of FCE here in this equation, it is FCE 60 by root 3. So 18 by root 3 means FCD plus 60 by root 3. So 18 by root 3 minus 60 by root 3 equals to FCD. This one will give minus 42 by root 3. So by this way we can get the value of FC. Let's take joint D. Joint D. So the FBD of joint D. In joint D, there is a support reaction called RD, and the value of RD here is 21 kilonewton. We are having two members. So we can show the forces in members according to our assumption, that is tensile. So that is FDC. This one is FT. And this angle is 60 degrees. So now we are interested in only in the value of FTE because CD is known for us. So only one equation is required for finding one unknown. So I am applying only one equation. Algebraic summation of all horizontal forces should be 0. In horizontal direction, positive axis positive, negative axis negative. So we are having minus FDC cos 60 because it is in negative direction, this component, minus FDE equals to 0, and we know the value of CD. So CD or DC will be same, so it is minus 42 by root 3, and value of cos 60 is nothing but 1 by 2 equals to FDE. So this one will come around 21 by root 3 kilonewton for FDE. So the value of FDE will be 21 by root 3 kilonewton. So now we can easily provide the table which will mention the member magnitude and what will be the nature of force. It may be tensile or compressive. So I would just like to mention earlier we assumed that all the forces in the members are tensile. If suppose the sign of the force is coming positive, it means our assumption is right. Means positive means it's tensile, and if it is coming negative, then it will be compressive. So let's draw the table which will show the forces in the members, which will show the forces in the members. This is the table. Here we are mentioning certain things. This member, this is magnitude of force in kilonewton, and this one is nature. Nature means tensile law. So first take an AB. Here AB, the sign is coming negative, but magnitude is 38 by root 3, and sign is coming negative. It means it is compressive. Compressive. Similarly, for BC, again the magnitude is 30 by root 3 and sign is coming negative, so it is compressive. Similarly, for CD, the magnitude is coming 42 by root 3 and sign is coming negative, so it means the nature of force in member is compressive. Similarly, for DE, the magnitude is 21 by root 3 and sign is coming positive, so tensile. Similarly, for EC, the magnitude is 18 by root 3 and sign is coming positive, so tensile. Similarly, for EV, magnitude is coming 22 by root 3 and sign is coming positive, so tensile. Similarly, for AE, magnitude is 19 by root 3 and sign is coming positive, so tensile. So by this way we can easily analyze the truss with the help of method of